Hi everyone. In this lesson, we will calculate all the air flows for each room, for the ground floor and for the first floor in the project that we will begin. First of all, let's create our ground floor and the first floor. Here I have the external reference file for the ground floor. Mm, First, let's attach it in a drawing to to begin our plan, to begin our project. Okay, so to attach this external reference file in a file, we need to create here a drawing. I will set it to millimeters for the for the units. UN is the command. Here I will select millimeters, and now I will attach our external reference file. Click, the command is XR. This window will open. Click here on the DVG and select our external reference file from the place that you saved it. My plan in this folder, ground floor layout. Okay, okay, and here it is. You can see that is an external reference file, the the architecture plan that we modified earlier, that we simplified earlier. Okay, let's save it somewhere. um, let's do here a folder. Okay, let's give it a name. Okay, this is the name, ventilation ground floor. Okay, I will close this external reference file. Okay, and the advantage of using external reference files is that if you have like 10 drawings in which you attached an external reference file, you only have to change the external reference file once, and it will update in all the 10 drawings that you have. It's a much more simplified way to work, and it helps us a lot in drafting. Okay, mm, let's see now for the calculations of the airflows. Um, let's create it in an Excel file. I have here the Excel open. Let's let's do a table with all our airflows for each room. For example, we have here, let's begin with the truck repairs hall. Um, let's put this here in Excel. I mean, let's create a table now for to begin. give it this name. I gave it this name to the table. Now let's do like this: room name, first column. Here we will write the surface of the room. Here the height of the room. Here the number of persons in that room. Occupants. And here the airflow that we will calculate for each room, and it will be in cubic meters per hour. Okay. Okay. Now let's see. First, we have the truck repairs hall. For this hall, we need to take 2 air changes per hour. Okay, this means that the air of the entire hall will change once per half an hour. Okay, it has a very large volume. This is why we will take only 2 air changes per hour. Okay, let's write here the name of the room, the surface. Now I will do a rectangle. I mean, we have these surfaces. We have these surfaces on the architectural plan. Let's open that for the surfaces. Okay, we also have this in the resource tab that I provided to you in the last part of the course. So I open this plan and let's see. It has 1058 square meters. Let's write it here. Okay, let's see now the surface of this hall. I will search for the height here on the sections. It's 735 meters. We don't here when we calculate with air changes per hour, we don't need the occupants of that room. Okay, so we leave that blank, and the airflow here is, we will calculate the surface times height times 2 air changes per hour, and we can see that we have here 15,500 cubic meters per hour of air, of fresh air, this space needs to be ventilated. Let's do here airflow calculated. and in the next column airflow installed. If we have a number like this 1500 and 15,500, we will approximate this value. So we will have here 16,000. Okay. It is also good to provide an extra airflow for the air handling unit. So we need to be prepared for every modification that can appear in the future. Let's round this sum up. So if it's 15,500, let's say here 15,600, because it's not 15,500 exactly. Okay, so we round it up and it's 15,600. Okay, for the truck repairs. So let's move on now to the next rooms. Here we have the boiler plant. We will ventilate this through a grill mounted in the external door. So it will not be a mechanical ventilation here. It will be a mixed one, because we will supply air through a grill in the external door, and we will exhaust the air through a fan. Next, here is a general storage, in which we will provide also air changes per hour. Okay, it's a general storage where there are boxes deposited there, so it's not highly vitiated air. Okay, let's write it here in our table. Let's see the surface and height. Let's hear the surface. The surface is 21 square meters. And the height is, let's see on these sections. So every room here at the ground floor will have the height of 270. Okay, here we have 270. 270 is the height of the rooms from the ground floor. Let's write here 270. 2 air changes per hour. Let's do this. We can drag this formula down, because it's calculated in the same way as for the truck repairs. The surface multiplied with the height and with the 2 air changes per hour. You can see them here. You can see the formula here. So it's 113. We will round this up, and we will install 120 cubic meters per hour of fresh air for this space. Let's move on. For the part storage, we have similar calculation. To air changes per hour. Let's write it here in the table. Let's see the surface, and the height we know, that is 270. It's 28.5 meters. The height is 2.7, and the calculated airflow, let's drag this formula down, is 160. Let's round it up. Okay, next, the office. Here in the office we will calculate differently the airflow, because that is a space with human occupation permanently. So first let's write it here. The surface is 9 square meters. 2.7 is the height. Occupants, the occupants for each human occupied space is taken depending on the furniture. Here we have only one chair and only one table, so this means it's only one person that will occupy this space permanently. I mean in the hours of work. So it's only one space. Let's write it here in the table. And here on the airflow calculation, we will calculate with the following formula. So again, when we have a human occupied space, we'll calculate with the following. We need 25 cubic meters of air per hour for each individual. Here we have one individual, so the formula is 25. This is the airflow for one person per hour, multiplied by the number of persons. In this case, it's only one person, plus 1.26 multiplied by the surface, and that is 9. Okay, and enter, and this is the airflow that we need for this space. The number 1.26 is from the normative and is taken for new buildings, because maybe you know, like for example, when you enter a new apartment that hasn't been occupied before, there is a certain smell of building materials. Okay, so we need to ventilate that also. So when we round up this value, let's say it's 40 cubic meters per hour. Okay, let's move on. Here in the dining, we will have the same formula to calculate the airflow like in the office. Write it here in our table. Let's see the surface. It's 11.7 square meters. The height is 2.7. Number of occupants, we'll take it from the architecture, from the furniture, and we can see that there are 4 occupants in that room, in this room, because there are 4 chairs here. Let's write it in the table, and we will use the formula for the office, and we can round it up to, you see is that it's 114, and we can round it up to 120 cubic meters per hour of fresh air, of fresh treated air. The air will be treated by the air handling unit. Let's move on here to the dressing room and to the shower. Here we will calculate the airflow like in the hall and the deposits. So let's write it here in the table. Let's see the surface. Now we will sum these two surfaces together. So it's let's sum these surfaces together. So it's 12.9 plus 3.6, and we have 16.5 square meters. Let's write it here in the table. We summed the two surfaces together because we will treat this like a single space. We will supply air from the air handling unit and we will exhaust it, okay, with a fan. The height is also 2.7. The occupants is not important here because we will use here 8 air changes per hour because it's a highly vitiated air. Because of the showers there will be high humidity, so we need to ventilate, to extra ventilate, to say so, this space because it's highly vitiated air there where we have showers. So the formula is like this, like in the truck repairs and storages, but the air changes are 8. So let's do like this: the surface multiplied by the height multiplied by 8 air changes per hour, 360, 356, and we will round it up to 360. Let's move on. Okay, so now let's treat this bathroom where we don't have showers. So when we don't have showers, we will have 6 air changes per hour. So let's see the surface. It's, let's say, 6 square meters. 2.7 is the height, and the calculated airflow is surface multiplied by the height multiplied by 6. So let's round this up at 100 cubic meters per hour. Next we have a storage here at 5.25 square meters. Let's write it here in the table. Let's say it's 5.5. The height is 0.7. We will have 2 air changes per hour like in the other storages. Let's round it up at 30. And the last room from the ground floor is the reception. Here we have only one person, but we can see that we have another 2 chairs here. So let's say it's 3-person room, and the surface is, let's say 27 here. It's 26.74, but let's calculate it by 27. 2.7 height, 3 occupants, and we will calculate like we did for the dining and office. So it's the number of occupants, 3, multiplied by 25. So again, 25 cubic meters per hour per person, multiplied with the number of persons, plus surface times 1.26. So it's what, 110 cubic meters per hour of fresh air. So this is with the ground floor. Now let's move on to the first floor, and again attach it in a file like this. Set the units first. It's in inches, but I will set it in millimeters. Click XR, I mean with the keyboard. Click on DVG here up, and here we have first floor layout. Okay, close this menu. Here it is, save it. Here on the ventilation project, or how you named it on your computer. Let's name it ventilation first floor layout, first floor. And let's continue with our calculations. Okay, here is the truck repair hall. We already calculated it. So let's move here to the director's office, where we have 7 persons. And let me open the architectural plan to see the surface. You can see that there is a 28 square meters room. Let's add it in our table. Let's do a separation here. Let's name this ground floor and here first floor. .28 square meters. Let's see the height of the room now to see height of the rooms from the first floor. It's 2.6 here. Seven occupants. Okay, and again, like with the same formula that I showed it to you. Number of persons times 25 plus surface times 1.26. So it's 210. Let's say 215 cubic meters per hour. Let's see the other rooms. Here we have an air hive that we also need to ventilate. Right in the table, the surface is 7.5 here. The height is 2.6. We will calculate it like the storage is, so 2 air changes per hour. So here surface multiplied by height multiplied by 2 air changes per hour. Round it up at 40. Next room, accountancy 1 with a surface of 21.5. There are 9 persons here, like we see on the furniture on the plan. Again, 9 persons multiplied by 25 plus surface multiplied by 1.26. 252, let's say, is 260. Accountancy 2 here with an area of 18, let's say. .6 height. Let's see the number of persons. 5 persons. 5 occupants. This is the same formula as for the accountancy one. Let's drag it down. And 150. Okay. Next, kitchen, where we have 8 persons and area of 14. .6 height, 8 persons. The same formula for the accountancies. And 220. Good. Let's go further. Here we have 2 bathrooms, one for men, one for women, one for women. Let's see the surface. It's the same surface, let's say 4 square meters. We'll take like exactly like from the ground floor where we had where we had a bathroom without showers, and we took there 6 air changes per hour. We will do here exactly the same. So surface multiplied by height multiplied by 6. So let's say it's 70 cubic meters per hour of fresh air. Let's do another row here for the women bathroom. For 4 square meters, 2.6 height. The formula is exactly the same, and also 70 cubic meters per hour. Okay, let's see. And the last room is the technical office with 6 persons and with 19.5 area surface. Two point six is the height, 6 persons, and again because it's a human occupied space, we will calculate with the right formula, and that is 25 cubic meters of air per person times number of 4 persons plus area multiplied by 1.26, and it's 180 rounded. So this I saved it and now let's do like this table with our data here. Okay, so this is our table. We can style it up a little here because we want it to look as better as possible. Let's give it the color. Okay, so there you have it. This is the calculations for this hall. The two formulas I showed you are the most common, and you will use it all the time, these two formulas. So it's very important to know them, and you will use it in 99% of cases. Now let's talk about calculations for smoke exhaust. For mechanical smoke exhaust, let's say if you have 100 square meters of a space that needs to be uh, smoke exhausted, this is how you calculate it. You can see the formula here. You multiply the surface by 36, okay, and the airflow installed minimum is 5,400, okay. So if the calculated result is below 5,400, then you should take the minimum. Okay, the minimum is 5,400. Okay, it doesn't matter if it's an 10 square meters room. The minimum smoke exhaust flow is this 5,400. Okay, you have to calculate the airflow with this formula, and if it's below 5,400, take the minimum, this 5,400. Or if it's, let's say, bigger, the airflow calculated, then the airflow installed is equal to the airflow calculated. So in this case it's 18,000. Okay, good. And for the pressurization is supplying a large amount of air in a space so that the air pressure will go up very much. So in case of a fire, the smoke from the nearby rooms won't enter this safe space. It must be safe for people to evacuate from the building. You need to pressurize uh, escape routes that don't have a window to the exterior or don't have a way out straight to the exterior. So this is calculated by taking the biggest door in the escape route dimensions. So if we have zero point 0.9 and zero point 0.9 is the width of the door and 2.1 is the height of the door. Let's say this is the biggest door in an escape route. We have to calculate it like this. The airflow supplied to pressurize this escape route. So you multiply the door dimensions by 0.5 and by 3,600. Okay, 0.5 is the airspeed when someone's open a door. Okay, while this space is pressurized, the air has to have a zero point 0.5 meters per second speed. And 3,600 is the transformation from seconds to hour, because an hour has 3,600 seconds, and you round up this value and it's 3,400. Okay, we will talk more about smoke exhaust in the smoke exhaust lesson. This is how you calculate when you need calculations for smoke exhaust. For natural smoke exhaust, we don't need calculations because the compensation air, this is the fresh air, is supplied through doors or windows, and the smoke is exhausted through windows or hatches in the roof. Compensation air is fresh air in case of a fire. This is how we calculate airflows for smoke exhaust. It's very simple. We will learn more in the smoke exhaust lesson. In the next lesson, we will begin to draw our project based on these calculations. We will place diffusers and the equipment that we need. We will choose an air handling unit. Okay, and for the air handling unit, we need to do a calculation of air that it needs to vehiculate. So let's do it now. Let's sum up the install the airflow to see what air handling unit we need. So let's do this. I will write here air handling unit, and here sum these values, type sum, open bracket, close the bracket, plus sum, and again you see the formula here. Okay, so this is the airflow for the air handling unit. Let's move this here, and here we will add 10% to this, because like I said before at the beginning of this lesson, it is possible to appear some architectural modifications, and we don't want to choose again another air handling unit in the future. So we will need to put an extra 10% of air that the air handling unit can vehiculate, to be prepared for these possible architectural changes. So let's add 10% to the calculated and rounded airflow we have here, okay? And to do this, we multiply this result by 1.1 to add 10%, okay? So it's 19 and 700, let's say. Okay, we will choose the air handling unit and begin to draw our project. Choose diffusers, equipments, and all that is to do to draft on the plans and do our project. So see you in the next lesson.